And welcome back, guys. This is Chris here with another tutorial session on manufacturing process part 2. Hopefully you guys had a chance to create your chair-based design on your own, right? And if you haven't, today we'll be making it so you can follow along. We will be making not this but something simpler than this to be exaggerates its design consideration, right? So let's get started, right? With this specific requirement, just remember your weight, your diameter, your hole size, center hole size, and caster wheel hole size and depth is all required in your consideration, right? And other than that, before we get started, I want to actually top up some info, right, that I've missed previously. I will have included this in the description, right? This is 11 injection molding defects and how to prevent them by AQF team. Thank you for your blog. And this is important because you want to understand before you start doing, right? You need at least some theoretical knowledge before you can start doing, right? So you don't need a lot, but you need some. So hopefully you can read through this. The main part of this that you need to watch out for is, for this tutorial session at least, it's warping. You need to have uniform wall thickness, yep, and part symmetry, right? So your don't just ensure that your part isn't too crazy, okay? And then we have sink marks. The rest is more towards manufacturing, right? But some of it we can actually change. Sink marks, design your tool, your mold with thinner component wall so that it actually cools down properly instead of, liquid doesn't cool in time lah. Yeah. And then other than that is the final one is short. So you try to make it so that this one is cooling too fast, right? So this one they need wider gate channels or gates, right? So you try to create parts that aren't too constricted as well, right? Other than that, it's best to top up information as well. And for sink marks, right, you can have this diagram here to be able to understand. So this part has two tick. You can see here is thick, okay, then have ribs here, then suddenly this part is very thick. This is potential sink marks area, potential sink marks. All this potential sink marks. So how to prevent that is through, instead you design like this. Move out your center hole more and pull ribs that connects them together instead of joining them together and causing a thick wall there. Okay, so then we get started with different designs, right? I have 3 designs here, and you could see that they are obviously quite heavy, especially this one. So this is called a dual hub design. You have 2 hubs, 1 hub, 2 hub, 1 hub, 2 hub, right? First hub, second hub, right? And this is called a single hub design. It's just 1 hub, 1 hub, 1 hub. So the main thing is that the hub is actually connected all the way. That's called dual hub design. And dual hub design has its own pros and cons, but at least for this tutorial where we're not worrying about worried about twisting like that, it's just the force going down. Dual hub design is actually not a very good design for structural integrity, right? Because the force distribution is not too good when you have a dual hub design, right? It will force distribute here, and then here will be a high pressure point, right? High stress point when compared to a single hub, because this part is going to be static, right? Static. So how do you explain static? It's like this part is going to be connected to the hydraulic piston, right? So it's going to be absorb all the force there, and here instead it's going to be dispersed out over here instead of here, right? So if you have a second hub design, the force distribution is not so nice. And what is called a good force distribution? Let me just pull this down in the end. Here you can see this is a better force distribution than this, even though this has more blue and this has less blue. You can see here's more yellow, but this means better force distribution because it's either your yellow part and blue part here, right, encompasses most of it, right, and your red part is very minimal, right? So excuse me. So yeah, so this is when you think about force distribution, and this is why you have tapering, right? Tapering is when you have thick and thin, right? So it's thick to thin. The more you taper, the more your force distribution is, right? So you don't have so much of a stress, right? Imagine brittle and flexibility. You want flexibility rather than brittle, and that's why we choose for material, we choose PP copolymer. If you remember for previously, PP copolymer is also more flexible, right? So this is what you want. You will have displacement, so do not worry, but it's not really a concern for this tutorial at least. So to maximize that, you want a high moment of inertia, right? High moment of inertia. And you could see here, high moment of inertia is dictated by this formula here. I equals to bh square, bh to the power of 3 divided by 12. So this is not important, but you can see that B, which is your base, affects your moment of inertia as well as your h. But h affects more. H affects to the power of 3. So by increasing h just by a little bit, it is already to the power of 3 times the amount of B of your base here. So this part you can keep it thin, and the height just make it tall, right? So that you can create a higher area of moment of inertia and better structure integrity, right? So you can see here in these two examples, if you're seen, right, you can see other than force distribution with the tapering here with a thick to thin, alright, more exaggerated thick to thin, right? You can see this height is this part only, is 70 when compared to this is 110. You can see the difference in MPa. This is 24. This 0.1 means to the power of 10. So you need to move one decimal point here. So this is 24 MPa, right, for 70 mm. If we increase it just by 40%, right, it basically divides it more than half. That is the power of the formula. So you need to understand the formula, and then you'll be able to better create your own design. These are all design considerations and engineering terms, right? So here you can see this is why it's important to make it tall and thin. Tall and thin, because B does not affect much compared to H, right? Tall and thin. Okay, so let's get started with the modeling. What was I missing? Yeah, okay. So let's get started with the modeling. You can see here, design ribs, single hub. It's also single hub. Single hub is better, right? For this purpose at least. So let's create a new part. I've created a part here, and we come to see our the chair-based design specifications, right? So let's start off with adding your material. Under here, under edit material, type in PP, and like we say, we want more flexibility compared to rigidity and brittle. So we don't need to be brittle and form cracks, right? Because you'll be sitting it, moving it around, So we use PP copolymer for this tutorial, and let's start with our base. So we'll be making a part here, then another circle outside. So this part is going to be 50. Oh, it's 5. Okay, it's 50 mm, right? Change this to 50 mm. 50 mm, and then the outer wall, nominal wall thickness is going to be 3. So 3 will be create more structure. Yeah. So the thicker your wall is, the more heavier your thing is going to be. Your part is going to be. However, it also able to absorb more force, right? Yeah. Then we're gonna extrude it by, I don't know, 110, 120. Why not? Let's go with something different this time. 120. Alright, and then we will create our inner wall. This part. So this will be the tapering effect. So you can see thick, thin. Alright, you need a minimal here, which is 25. Right. However, thick and thin, important. So why is my relations not showing? Yeah. So here, and in this part you can see it's if you extrude this out right later, it's not going to encompass the entire thing. So you want it to go in a bit. Right, in a bit. Just slightly. Halfway. Make this not vertical. Horizontal, then this vertical. Right. So you have something similar to this. The height of this does not really matter for this context because we are not actually injection molding it, but you should have a certain amount of height, because when there's a force applied, right, force applied at the bottom here, force applied is going to be applied here, then just your starting point, right, is going to push outwards, and so it's going to be displaced, right, displacement, so you need a certain amount of height. But for this context, it's not going to matter too much, right? If you design it well, the displacement is not going to be too much yeah, but that is not much of a consideration for this part So The diameter of this should be 720 divided by 2. Right, so you get the radius, which is 360, right? And then we have this part. The height is 25. Wait, the height is 25. Oh, it wants 25, so we can't have 25. 11 diameter, we use 20, I guess. 20, then 35, we just put 30, just to be sure. Less tapering, but it is what it is. And then, okay, then now we extrude it using midplane. There is no the B here, right? The base thickness here, not really too important. We just go for something minimal like 20, I guess. Yeah, 20 is fine. It's a square, right? It's a square. Yeah, it's a square. Okay, because we want to exaggerate the effects, yeah. So hopefully you guys can do it later on differently. We will cut this out. This is in preparation for later. So this is going to be here. Then we'll slice this later. Let's fillet this first, so that we don't have any too round of an edge. Twenty is a bit too much. Something like 8 instead. Yep, nice. Here. Okay. Done. Okay. Then this part can be released correctly, right? So A part move up. Okay, can. Then, by the way, A B part is talking about this one, A and B. So as long as it can be can be pulled out, injected properly, then it should be fine. You just don't want a inverted overhang or something. And then here we cut off this line through all. That. Okay, there we have it. Then we can have a shell. Let's shell this out. There's 3. Show preview. I think it's okay. Oh, we just made them. Okay, that's it. So you made this. So this is your single hub design, right? And then there's this here. As you see, this is very different from my previous design, because that is actually this one, right, where it curves to the side. We don't have that. And previously when I've done this, right, most of the force goes here rather than here anyway, because we don't have any twisting force, right, which is not our consideration for this tutorial. Then we have this, quite a very big taper, right? And then let's create our oh, I forgot to shell here. Oops, my bad. Here and here. Then. Okay, now we need to create an inner rib. For our inner rib, which is just a very simple. Yeah, it's flat, right? So we just use this as our base, and then we'll create a rib down here. Always extend your rib out a bit more, because if they have a curved surface, right? Here don't have but if a curved surface like this, the rib won't be able to fully encapsulate it, because it's curved, right? Same thing with this, yeah. Then you want it to extrude using thin feature. Up there, line. We use up to next, and mid plane. Oh no, up to next. Up to body is less memory. Let's use up to body. Then we use mid plane here. We put 3 divided by 2. That would be your rib thickness, right? Here, done. Then do you have excess here, right? You just cut it off, Cut it off. Just go with so that you can just. I think drawing yourself is faster, but let's just ensure there's no issue. Okay, so here, just convert entities, and then you'll have a surface plane that is able to can be sliced up basically. Click on this, click on cut surface, in your surface, click down, bam. Okay, then this one you want to delete your surface bodies. Yeah, here you do not want any surface body, because when you do your static simulation later, FEA simulation later, if you have any surface body, right, with no thickness, they don't know how to calculate that and just refuse to work, right? So this one is straight up, because later our force is going to be static, is going to be here, so there's going to be a infinitely rigid point, and then this point is where the force is going to be. And this is important because if it's connected like this, it won't spread out the force to the side, right? So this to exaggerate the effects there. And then we forgot our caster hole, so let's add our caster hole this time. Our caster hole diameter is 11, so let's make it 11. Sorry, my voice is a bit off today because a bit coughing. Didn't drink too much water. So here and this point should be, let's get the set midpoint of this, and then I'll 17 midpoint will be 11. Should not be an issue for 11. Caster hole diameter. Ooh, this is too thin. Yeah, you can see that caster hole diameter here, and if we use over here will be nominal wall thickness. Nominal wall thickness, you can see it will overlap here, so this means that it will cause a lot of issues later. So we need to make this a bit you can just come back to your previously built this, so you cause sync marks, right? So you do not want that to happen, so we go for 35 instead. 25 of this and 25 of thickness. Oops, 25 of thickness, 25 thickness. There we go. So that will not have an issue later. Here, no issue here. Actually, this one can just be ribs, right? We don't have to make it too thick. Yeah, let's just make it a rib. 1.5. Why do you need it to be so thick anyways? Doesn't make any sense. Because I'm scared I will have thin steel here if I make it what. It's okay, I'll just make this a bit thicker, and then we shall make this a bit, we can finally make this tree a nominal wall instead of a rib, which should be as intended. Then the fillet here, I think the fillet's a bit less, we go for roughly something like 10. Should be fine. Yeah, there we go. Then we will extrude the body here, merge results, return here, cut this, right? Then you'll have your hole here, circle all the way, then you slice not up to body, you slice up to surface, this surface, and bam, done. So you have a hole here. Is the caster hole a rib or a, I think it's a rib, right? Well, it is what it is. Too late now. And here we go. Okay, so you have one single rib here and your nominal wall. So that is basically your entire spoke chair based designer. And then we will need to slice this into into sections. So let me just put all this together. Yeah, whatever. Here's your model. And then now what we need to do is we need to slice this so that it's to prepare it for the cyclic symmetry and circular pattern, depending on what you want to say. Put it in the middle and down here. So here to here should be 360 divide by 5. So because we have 5 spoke chair base. Can I symmetrize it? No, they don't allow. Okay, fine then. 36 then. 36. There we go. Ensure this and this is not for construction. Then we don't want to cut extrude. We want to extrude surface. through all, and then we can slice this part. Should have no issue, right? Oops, wrong slice. I'm not supposed to delete that size. Okay, there we go. Then now we delete body. By the way, if there's any command you don't know, you just click under here, click commands, and then you put delete body. Yeah, or any command you want that you can't find lah. Yeah. Then here you have, yep, now it's prepared for cyclic symmetry, prepared for its curve. Then we need to go back to here, click on reference, create an axis. Right, then go back, roll back, and then now you can circular pattern it, or circular pattern. It's here. Circular pattern, you always click on body, not your feature. Remember that. Not 8, it's 5. Then there we go. And then can combine body. Yeah, done. So you have your 5-spoke chair-based design right here. Very simple, very easy, right? Not too big of a issue, right? You can see it's down here. It's pretty thick as well, and now we need to check our weight. So it's why you need to do this part is so that you can have something to show, and also need to check for weight, right? So checking for weight is under evaluate. If you don't have this tab, go to under toolbars, under tabs, and find evaluate ticket, and you can have your mass property. Oops. And here, let me just put this into focus mode. Put this as, it's a bit off of the grams, so it's not 1000, just a bit too heavy. Then we shall make slight changes lah. Maybe if we curve this a bit more, then it would not have that issue. 12, right? Curve the more, mass property. Ooh, almost there. You can change the weight of this, but I will change instead, since it's only just a little bit, right? I would change this to 28 instead. There you go. Right, 28 instead. So this is definitely under 1000 right here. You can always make this a rib, and then there's a lot of optimization you can do with this, but there's no need for optimization, right? I just need to teach you the tutorial on how to deal with this, right? So here, okay, this can come off. Okay, so now we have done this part, ensure everything's correctly before I end this, and prepare for the next tutorial session. This would be cut. Should be circular pattern. Okay, done. So there we go. We have a chair base with the weight, not over, and your material. So you have reached all your specification requirements. So before I end this, let's go with one final check by creating the drawing for this, right? This is important for your next tutorial and this tutorial as well. You will always want, every time you do something, right? I don't have an issue, but if you're doing something when you're exploring, right, you want to have a pattern here. So you want to have not pattern, you want to have a drawing, and this drawing is going to be able to show show you whatever issues you might have. Okay, any issues you might have, the drawing is there for you. Okay, so don't worry about it. So drawing is important. Then you can see, let me slice this. Section view, cutting edge. Okay, so you want to go to section view. Okay, so you have your top view. Let me just quickly add this in. Top view, top, right? Here's your front. Front is basically a useless view. You have your side, right? So your side view, top view, side view. You can always properly name this, but I'm too lazy, right? So section view, create under drawing section view. You want to cut this in half. so that you can actually get the half part of this, right? This is important, section AA. So this is where you will be able to find out if your part is actually 720, because later when we do drafting, when we do analysis, everything, right, all of this will change, right? It might change and it might not be 720. So over here you want to go to annotation, go to center line or center mark, center line, click on your here, click on this part, click on OK. Hello, center line. Do you not want? Click on this and click on this, I guess. Then center line and click on OK. It doesn't want center line. So odd. Click on here, click on here. Wait, where's my center line? Ah, screw it. Let's just draw one. Should be able to work, but sometimes a bit finicky. Just middle part and middle part. Not too big of an issue. Down here, and then you want to check your part. Is it actually? Always never click on this point, right? You want to click on the bottom point here. That's 360. Done. 360 mm, and bam. So you know this is correct. Then now you want to check your height of this to ensure it is 11. So you have 11, and this is more than your lowest point. It's more than 25. Done. Congratulations, right? You have made a chair base that fulfills all of these requirements, right? Very smart, very nice. Check our wall thickness. How do you check our wall thickness? Is you can slice this part, right? You want to slice down here in the middle. That's one of it, right? So that you have this part. This part, your section BB, and then using this you can check your height. So this is 30, this 3, this 3 point something. Not very uniform wall thickness here, but yeah, it is what it is. And you have your ribs. This is not your ribs, this is also a nominal wall. Wait, to get your ribs you need another section more behind. This is important because you want to check your drafting later, so that you need to do this as well, right? Ignore the other sections. We need to find out, this is still 3, right? Yes, it is 3. This is the middle part here, 1.5. It is 1.5. Great. Okay, so you got your drafting correctly. Not your drafting, you got your thickness correctly. Then in the future we need to fillet all of this, right? Or let's just fillet it now. Yeah, almost forget it, but it's important, right? Fillet. You okay, Solidworks? Hello? What is this, bro? Why is the GPU suddenly working like this? Okay, anyways, so now we need to fillet it. So to prevent thin steel, right, this is going to be sharp corner when they molding tooling, right? It will have a lot of issue. The more sharp it is, just remember, whatever you do in manufacturing, it can never be fully sharp. It can never be a fully 90 degree. It will have a very small fillet. Always having a very small fillet or chamfer. The more sharp it is, the smaller the fillet is. Okay, so let's just go back to cut, and then we need to fillet this. Let's go for 0.1, I guess, mm. So if you want something very sharp, go for something like this. Since the cardinal rules of injection molding parts states that 0.4 to 0.25. So that's just 0.25. 3 divided by 0.3 multiplied by 0.25. Oh, multiplies this, right? 0.25. I was wondering why it's not working. So 0.75. There we go. So that is your radius. So you want to round all of these corners off. It's already been smooth. So odd. Sure. If it's smooth, then it's smooth lah. Whatever. All of these corners off. Just click them one by one. Should have no issue here. Oops. There we go. Might as well run this as well. It's not really, it doesn't really matter much, to be honest, this one. I'm surprised though, this is smooth. Very odd. Very odd, not gonna lie, very odd. Right. And then this part we can curve it a bit as well. Curve it a bit. Just multiply this by 2. Just put 1 instead. Uniform wall thickness, right? Sure. Yeah, because I'm scared that this will become a potential sink mark area. Just need to ensure that it's not more than 5, so it should be fine. This one we have to do with our thickness analysis later on, not now. So now you have a filleted edge, a very nice curved edge. Bam, done. Might as well fillet this right, because why not? Let's be a bit extra. This part. Nah, we don't need it. Okay, it's not important. Alright then. Bam, there we go. You have your part here that you can use, and you have learned how to check with your drawing. Yep, congratulations. Oh, where's my drawing? Yep, here. Congratulations, you are very nice. You have succeeded. And here ends our tutorial for today. Alright, and hope you guys understand this part well and is able to fulfill it and follow along. Right, so I'll see you on the next tutorial then. Goodbye.